So moving on, I got a bunch of capacitors in a kind of, all you can eat kit. So what I've done is I've stuck a bunch in there. You can see the brown things. On one channel I've stuck them, and I was hoping to see the difference in just the one channel, but I'm not really seeing any significant difference. They're 1 nanofarads because I calculated it based on the RC. Is something getting hot? The smell. Oh, it's the heater. I've got an actual heater. Right. So I was looking at the capacitors and stuff and what to do, and I was thinking I can make a test circuit here like this so we can actually experiment with a single end. And I was thinking, so I could put 2.2 millifarad. It's a 22,000 farad microfarad capacitor, right? So we've got, now we're using a 12 volt supply, and check out the voltage on the capacitor. I didn't realise the 6.3. I used these on 12 volts and they were fine. Now we're not dealing with massive voltages here, so I'm guessing the kind of tolerance that we're talking about in the capacitor is going to be reasonably significant. It's not blown or anything, so I'm presuming it's fine. You know what I mean? These things, they blow unceremoniously, right? Like really do. I mean, the can end ruptures. You can see how it's got cuts in it. That's to actually stop shrapnel, so that when the can end ruptures, it actually ruptures in a predictable pattern. That's why it's got those cuts in there, right? And basically, the bottom end is plugged, right? So it always explodes this way, in its direction. Those cuts are there, not round. The whole thing is in a can, but this thing here is where it splits, and so it explodes out this way, right? Which is the presumption that's away from the circuit, so it's not going to damage anything else and stuff like that, right? And they do blow unceremoniously. What basically happens is inside, because it's like two sheets of aluminium rolled up very, very tightly with essentially a plastic coating between them, and they roll it all up into a nice round tube and then put it in the can. And what happens is that the insulation between the two contacts melts, right? And so the plates touch, and then you get a short across the capacitor. And the reason why they blow, like really, really cracking blow, is because the actual capacitor itself is holding energy, right? So when you get the internal short between the two plates, all the energy that's stored in that capacitor goes through that short, and so that's why it does that. That's why they do it like that, instead of it just being like an internal short, because you're discharging the energy of the capacitor through the short inside it. Now these haven't blown, and they would if I put a capacitor across this supply, right, that was like, say, 1 volt, I guess, or something. It would blow the bloody thing, or put it across an AC voltage or something like that, which is too high. So they're rated at 6.3, but they seem to be quite fine. It's actually running at 9 volts, but I'm pretty sure I've had them on when it was running at 12 volts. So I don't know. But the biggest voltage I've got are these ones, which are 1000 microfarad, 50 volts. Because I was thinking about this testing circuit here, where basically I have one pole of the motor connected to the output. I can't do that. One pole. Can I do it there? No. Can I? No. One pole here connected to the output. There we go. Let's just zoom out a bit. In fact, this is still too big. Right. Yeah, because we got, this is the digital output, and then we've got the driver circuit. These are the two outputs, and then I've got my which is this motor, of course, because you can see I've actually put the 6 coils in there, and it has 6 coils, and that's how they're connected electrically. And so what I can do is connect these through a big capacitor, essentially, to the ground, so that these then are held at well, the idea is to hold these at, like, 6 volts or something, right? Well, this is at 12, so it holds these at obviously it'll basically hold these all at the same voltage, and then as this is doing its PWM, you can actually get an idea of what it would be like in a real motor, because that's the sort of total inductance that you'll be driving against, so you get nasty frequencies and stuff like that, and you can tune them down. So that's what. Oh dear, go away. I know it is. So that's kind of what I'm looking at in order to do a single-ended test to try and get rid of the noise in the circuit. It's not so bad, but these guys, these guys are getting hot because of the noise that's going in through the gate. You see, let me turn that off because that's annoying. There, right. So you're getting noise going in the gate. So these things are not like switch and then off. They're like, brrr, you know what I mean? And so when they're doing that, brrr, these are getting hot then, and then they're then fully switched and then they cool down presumably. Do you know what I mean? But because that's happening an awful lot, then you're getting a problem. So we really need to get those down and get the frequencies down. Now I've also put in gate resistors here, and they're different. This is 20 and this is 100, and the reason why they're different is because these are actually not a symmetrical pair. This is a P channel. I think these cost like a £5 each or something, right? P channel, 60 amp, 60 volts, something like that, you know, reasonably high powered, so I can experiment with them. And these ones were like, you know, for the £5 that I paid for that, I can get a bag of 100 of these or something stupid like that. And these are the N channels. N channels are far cheaper because they're much more used. It's a supply and demand thing, right? But I wanted a P channel because I wanted to experiment with the circuit without having to bother with an N channel in there, because that comes with its own problems. However, I might actually develop a single end using 2 N channels, because there is a way of actually switching the gate, basically using a capacitor. So you charge the capacitor and then it discharges through the gate, you see, to actually do the gate switching. And I saw it in a circuit and I've still not seen it. And I really would like to experiment with a single end this way. So I need to set that up. I have my motor, which obviously isn't going to turn in this instance, but I can just connect it, put those 2 connections, put the VW connections onto a big capacitor, and I have one. I've got that one there. Yeah, that one's I've got 47,000 microfarad there, which is 400 volts, so it's fine. So I can put that on there, yeah, and maybe you know, load it up with some ceramics as well to try and you know, stabilize the noise on this point to make sure that it's as central as possible, or even put a capacitor on both sides, you know, to the 12 volt and to the ground, something like that. Yeah, and then I can set up my test circuit, and then we can get this down as low, and so the noise on this is low as. But what I really want is just want a straight switch like that, and then switch up, right? So I can then start messing around with this circuit and get it tuned so that it's as noiseless as possible. Yeah, but I don't know. So that's me. Something else. So I've got this scope. It's a bit primitive on the operating system side, shall we say. The scope itself is great, but it's just when I'm saving files, these files here, which are the output files, onto a USB, it writes them in a funny way. So the date isn't right, so I've just wrote myself a script. Where it is? No. Here it is. I just wrote myself a little Diddy script because the creation date's there, but not the modification date. So I had to put a bit of code in there so that it actually takes the creation date and sets that as a modification date as well. And then I can then see which. The problem is that the numbers the files have, now they're actually in the date order, you can see how they're incrementing there, right? But if I go to something a bit more historic here, and so you can see they're incrementing. No, they are actually incrementing there. What I've done is that these have actually got the right dates on them. That was it doesn't look right, but I actually was working on this in New Year's Day. Here's a good example, right? So we've got a bunch of them that are all actually on New Year's Eve. Is that right? No, it's the day before New Year's Eve, isn't it? And look at the numbers that they add to them. They're not really sequential, are they? So I can't really tell. And also these ones are obviously bigger numbers than the ones earlier. So it was like, what? How am I going to deal with this? So I found out the creation dates actually have the dates that they were created, ironically enough. And so I just wrote a script basically so that it sets the modification date, which is the thing that this orders it by, as you can see. and and this one as well, which means it makes it a lot easier for me to see which ones are which is good. So I found that out. Yeah. So it's a question of priorities now. I actually have got something that works, but it cooks still, and it's not quite right because it's running on 9 volts. But I think I'm trying to understand what the point of doing here. Obviously to build a motor, but the motor includes this bit and that bit. You see, so I need to develop both. So I'm thinking this I want to try and do with an AC induction. So I need to replace this with something that will actually do me AC induction, a squirrel cage basically, or even just a drum, right? So I need to think about maybe doing that. Yeah. And the other thing is I want to try and make it so that this is actually like an active electromagnet, not magnetic. So do I spend my time developing that, or do I spend my time developing that? I don't know. The trouble is that this gets cooked. You see, this gets hot. Yeah, really hot. And I haven't finished it because this is running on... I mean, I could just run it on 9 volts, I suppose. And if I put heat sinks on these, then it'll dissipate because they haven't got any heat sinks on. So if I just put heat sinks on these, and then that means it'll get the temperature down. Yeah. Because really I want to focus on getting this thing working. I don't really want to focus too much on that right now. However, I do need an inverter circuit, which is what that is, in order to drive that. And I was thinking about using these things, but they cook just as much and they're not as good. I was going to use those because they were easy, but yeah, turns out they're not. Yeah, so I don't know. So I need to think about what I'm going to do. But I think I just need to get some lunch, maybe.